In this video, we will practice finding the intervals where a function is increasing or decreasing. And for that, we will use the first derivative. So y prime will equal, we're using the power rule so that 3 is going to come to the front. I'm going to put it over the 4 that's already there. And then we will have x squared as we reduce by 1. So minus 3. This is the first derivative. Now we need to find the critical numbers. That's where y prime is either equal to 0 or where y prime is undefined. But this is a polynomial, so there is no location where this is undefined. So we can just focus on where is y prime equal to 0. So we just set y prime equal to 0 and solve. Adding 3 to both sides, we have 3/4 x squared is equal to 3. Multiplying by 4, that's 3x squared is equal to 12. Dividing both sides by 3, we have x squared is equal to 4. And taking the square root of both sides, we have x is equal to plus or minus 2. So you take these critical numbers and put them on a number line in order so you can make a sign chart. So let's pick a test value in each interval so we can determine if y prime is positive or negative. In the first interval, for example, we just need something that's less than -2. So how about -4? So if we let x equal -4, then that's -4 squared minus 3. So that'll be 3/4 times 16 minus 3. 4 goes into 16 4 times. 4 times 3 is 12. So that's 12 minus 3. So that's going to be positive 9. So all that really matters is that this is a positive value. In the middle interval, let's let x be 0. We can just do that mentally. If x is 0, this entire term is wiped out and we're left with a negative. In the last interval, let's pick 4 because we already know we're going to get the same answer. If we change this -4 to a positive 4, nothing changes because if you square a positive 4 or -4, either way you get 16. So you will get positive 9 again. So this is a positive. We have long ago memorized the graphical relationship between f prime, and f double prime. Right now, focus on this bottom part of the chart. We know that if f prime is positive, then f itself is increasing. If f prime is negative, f is decreasing. That tells us that in the first interval, the function is increasing. And in the second interval, it's decreasing. In the third interval, it is increasing again. So here's how you would write your final answer. Y is increasing from -infinity to -2 and from 2 to infinity because y prime is positive. Y is decreasing from -2 to +2 because y prime is negative. Make sure you include this justification. Before we find the derivative for number 7, let's rewrite the function a little bit. Let's bring this out of the denominator by writing it as x plus 1 to the -2 power. Now, let's find the derivative using the chain rule. So first we take the derivative of the outer function. So I'm going to put this -2 in the front. I have to subtract 1 from the exponent, so I will have -3. But then I have this stuff inside, x plus 1, and technically I need to multiply by the derivative of the stuff inside, but that would actually be 1 in this case, so we can just ignore that. So there is your derivative. Next we need to find the critical numbers. Actually, I'm going to rewrite this without the negative exponent to make it easier to see my next point. I'm going to drop this factor down to the denominator because of the negative 3 power. So we have negative 2 over x plus 1 to the third power. So the critical numbers are where the derivative is either equal to 0 or where the derivative is undefined. So the derivative will equal 0 when the numerator of the fraction is equal to 0. But the numerator is a constant, so there's no way for that to equal 0. So we can forget about this. So let's focus on where f prime is undefined. That's where the denominator is equal to 0. And at a glance, you can see that if x is negative 1, that's when you will get a 0 denominator. So this is our only critical number. So let's put this on a number line and make a sign chart. So here is our critical number on the sign chart. I'm going to look at this as two factors. We have the negative 2 in the numerator and the x plus 1 cubed in the denominator. So I will need 2 rows on my sign chart. Be sure to label your sign chart as f prime. Now we need to determine whether each factor is positive or negative in each interval. Well, negative 2 is always negative, so we can just go ahead and mark that off. X plus 1 to the third power. What about a value that is less than negative 1? For example, if we substitute negative 2 for x, then that would be negative 2 plus 1. That would be negative 1 to the third power, which would be negative 1. So we get a negative value. A value greater than negative 1 would be 0. So you could just do that mentally. If you put 0 in for x, then you're just going to have 1 to the third power, which is positive. A negative divided by a negative is a positive. So f prime will be positive in this interval. A negative divided by a positive is a negative. So f prime will be negative in this interval. But we know that where f prime is positive, the original function will be increasing. If f prime is negative, f will be decreasing. So that means that f will be increasing in this interval from negative infinity to negative 1. And it will be decreasing in this interval from negative 1 to infinity. Let's just write that up. So you would say f of x is increasing from negative infinity to negative 1 because f prime is positive. F of x is decreasing from negative 1 to infinity because f prime is negative. Number 17, let's go ahead and find y prime. So this will be 2x minus 4. We can write this in factored form by factoring out the 2, so that'll be x minus 2. We need to find the critical numbers, and that's going to be where y prime is equal to 0. There are no values that will cause this to be undefined, so we don't have to worry about that. So setting this equal to 0, we get x equals 2. So this is our one and only critical number. Let's put that on a number line and make a little sign chart. Make sure you label the sign chart as y prime. I only wrote down the x minus 2. The constant of positive 2 won't change anything. So let's see where x minus 2 is positive and negative. So for values of x that are less than 2, x minus 2 will be negative. For example, if we put a 0 here, this would give us negative 2. For values of x that are greater than 2, y prime will be positive. For example, if we put a 3 here, 3 minus 2 is positive 1. We have learned that if f prime is positive, f is increasing. If f prime is negative, f is decreasing. That means that the original function will be decreasing in this interval from negative infinity to 2, and it will be increasing in this interval from 2 to infinity. Let's just write that up with a justification. Y is increasing from 2 to infinity because y prime is positive. Y is decreasing from negative infinity to 2 because y prime is negative. Switching gears a little for this next one, we are now being asked to determine the intervals on which the function will be concave up or concave down. For that, we will need the second derivative. But of course, to get the second derivative, first you have to get the first derivative. So this is going to be pretty simple with the power rule. The 3 comes down to the front. It's 3x squared. 2 times 6 is 12. And then minus 9. So there's the first derivative. Now we will find the second derivative in the same way. 2 times negative 3 is negative 6. And then plus 12. Let's go ahead and write this in factored form to make it easier to find the special numbers, which I would normally call critical numbers if it was the first derivative. So this will be minus 2. So next we need to determine the numbers for which f double prime is equal to 0 and the numbers that will cause f double prime to be undefined. However, f double prime is a polynomial and there are no x values that will cause it to be undefined. So we can just focus on where it will equal 0. And you can just visually see that if we were to set this equal to 0, we would get x equals 2. So this is our only special number. Let's go ahead and put this on a number line and make a sign chart. So you can see our special number of x equals 2 on the number line. Be sure to label the sign chart as f double prime. So I made 2 rows because I'm going to give negative 6 its own row. All right, a negative value will change things. And I will give the factor of x minus 2 a row. Now we need to determine if these factors will be positive or negative in each interval. Of course, negative 6 is always negative, so we can just mark that off. X minus 2 will be negative for values of x that are less than 2. For example, if we put 0 here, we would have negative 2. So it'll be negative in this interval. And similarly, it will be positive in this interval. If I pick a value greater than 2, like 3, we would have 3 minus 2, that's a positive 1. What about the overall value of f double prime? A negative times a negative is a positive, and a negative times a positive is a negative. For this question, we are being asked about the concavity of the function f. And we have learned, maybe I'll show it again. When it comes to concavity, if f double prime is positive, then f is concave up. If f double prime is negative, f is concave down. That means function f should be concave up in this interval from negative infinity to 2. And it should be concave down in this interval from 2 to infinity. Let's go ahead and write that up. So we can say f of x is concave up from negative infinity to 2 because f double prime is positive. F of x is concave down from 2 to infinity because f double prime is negative. We can also say something about a point of inflection because we see that f double prime goes from positive to negative at x equals 2. Let's add that to our final answer. We would say f of x has a point of inflection at x equals 2 because f double prime changes signs.